The admissibility verification model, why systems must be tested for forbidden states. Modern systems are usually judged by whether they work. A policy works if it is implemented. A software system works if it runs. An AI tool works if it produces useful outputs. A consulting intervention works if it delivers a result. An institution works if its procedures continue to operate, but this is not enough. A system can function and still become dangerous. It can comply and still become unfair. It can perform well and still become illegitimate. It can automate decisions and still obscure responsibility. It can improve efficiency and still produce dignity loss. This is why P introduces the admissibility verification model. The purpose of the model is simple: to test whether a system can enter a state it should never be allowed to reach. This is the difference between performance and governance. Performance asks, does the system work? Governance asks, what can the system become? The admissibility verification model is inspired by the discipline of systems and software verification. In formal verification, a system is not trusted simply because it appears to work. Its possible states are examined. Its transitions are analyzed. Its required properties are specified, and the system is checked to see whether it can violate those properties. If it can fail, a counterexample shows the pathway into failure. PI takes this logic and applies it to governance, AI, policy, consulting, and institutional design. Human systems also have states. A policy can enter a legitimacy loss state. An AI system can enter an authority confusion state. A consulting intervention can enter a burden transfer state. An organization can enter an identity fracture state. An institution can enter a capture state. A public system can enter a trust collapse state. The danger of a system lies not only in what it is today, it lies in what it can become tomorrow.
The admissibility verification model asks 7 questions. First, what kind of issue is this? This is the stage of ontological classification. Before a system can be verified, the issue must be classified correctly. Is the problem technical, epistemic, ethical, identity-based, narrative, legitimacy-based, symbolic, phenomenological, governance structural? This matters because the wrong classification produces the wrong test. A legitimacy problem cannot be solved by communication metrics alone. An identity problem cannot be solved by efficiency targets alone. A fairness problem cannot be solved by cost control alone. An AI authority problem cannot be solved by accuracy testing alone. P's warning is clear. Verification cannot rescue a misclassified issue. Second, what must remain true? This is the stage of admissibility property specification. A system is not admissible merely because it produces outputs. It is admissible only if certain conditions remain intact. Human accountability must remain visible. Authority must remain legitimate. Fairness burdens must not be hidden. Users must not mistake assistance for final authority. Dignity must not be structurally violated. Appeal pathways must remain available. Temporary powers must remain temporary. Responsibility must not disappear behind the system. These are admissibility properties. They define what must always hold, what must never occur, and what must eventually be corrected. Third, what states can the system enter? This is the stage of governance state space mapping. Every serious system has a possibility space. It can enter normal states.
stress states, drift states, failure states, capture states, authority confusion states, legitimacy, loss states, identity fracture states, meaning collapse states, responsibility obscured states. The question is not only whether the system is acceptable now, the question is, what states are reachable? A system may look safe in its normal state, but if it can reach a forbidden state under pressure, scale, ambiguity, or institutional incentive, then it is not yet governed.
Fourth, how does the system move from one state to another? This is the stage of transition analysis. Many failures do not happen all at once. They happen through transitions. Assistance becomes authority. Consultation becomes symbolic theater. Temporary power becomes permanent control. Efficiency becomes burden transfer. Automation becomes responsibility loss. Digital access becomes digital exclusion. Accuracy support becomes false expertise. Compliance becomes legitimacy collapse. The model asks, what causes these transitions? What incentives push the system toward danger? What ambiguity allows role confusion? What feedback loop reinforces failure? What pressure accelerates drift? What constraint is missing? A system is not only defined by its structure, it is defined by the transitions its structure allows. Fifth, what counterexample proves the system can fail? This is the stage of counterexample search. An admissibility counterexample is a concrete scenario showing how an apparently acceptable system can enter an inadmissible state. For example, an AI assistant is labeled as informational, but a vulnerable user treats it as professional authority. A policy is procedurally compliant, but one affected group experiences humiliation and loss of voice. A digital transformation increases adoption, but vulnerable users lose practical access. A restructuring saves money, but institutional memory collapses. A consultation process is completed, but stakeholders experience it as symbolic theater. These counterexamples are not nuisances. They are evidence. They reveal the path by which failure becomes possible. The purpose is not to block action. The purpose is to make action admissible. Sixth, what must be redesigned or constrained? If a forbidden state is reachable, the system must be changed. The model asks, what boundary must be clarified? What authority must be limited? What accountability must be visible? What appeal mechanism must be added? What burden must be redistributed? What decision must remain human? What must remain reversible? What monitoring must be introduced? Possible constraints include human review, appeal pathways, sunset clauses, role boundary disclosures, responsibility labels, burden monitoring, independent review, interface redesign, or slower deployment. The aim is not to remove all risk. The aim is to prevent forbidden states from becoming reachable without constraint, review, or correction.
Seventh, what must remain true over time? This is a stage of temporal monitoring. A system may be admissible at launch and inadmissible later. An AI tool introduced as support can become de facto authority. An emergency measure can become permanent. A dashboard introduced for oversight can become surveillance. A consultation process can become ritual. A digital access system can become exclusion by default. This is why admissibility must be monitored across time. The model asks, what signals show drift? What assumptions may decay? What thresholds trigger review? What temporary permissions must expire? What happens when users become dependent on the system? What happens when the system becomes normal? governance does not end at approval. Governance begins again at every transition. The admissibility verification model can be applied to AI governance. It asks, can users mistake AI output for professional authority? Can fluency be mistaken for understanding? Can simulated care be mistaken for duty of care? Can responsibility be displaced onto the machine? Can human accountability become invisible? Can assistance become decision substitution? These are not merely technical risks, they are forbidden governance states. The model can also be applied to public policy. It asks, can the policy remain legal but lose legitimacy? Can it solve one problem while creating unfair burden? Can it exclude vulnerable groups while improving aggregate performance? Can it drift beyond its original justification? Can public cost become private gain? Can administrative convenience become coercive structure? The model can also be applied to management consulting. It asks, is the client measuring the right success condition or savings masking burden transfer? Is adoption masking identity damage? Is compliance masking trust loss? Is the intervention solving the presenting problem while deepening the real one? And it can be applied to institutional design. It asks, can authority become detached from accountability? Can procedure replace legitimacy? Can feedback loops collapse? Can the institution preserve contradiction rather than correct it? Can compliance become a substitute for responsibility? The admissibility verification model gives P a practical tool for moving from interpretation to verification. It does not mechanize human judgment. It disciplines it. It does not replace ethics. It makes ethical and governance conditions explicit. It does not replace leadership. It tells leadership what must be tested before confidence becomes dangerous. The model can be summarized in 7 steps. Classify the issue. Specify admissibility properties. Map the possible states. Analyze the transitions. Search for counterexamples. Redesign or constrain the system. Monitor admissibility over time. The central principle is this: a system is not admissible because it functions. It is admissible only if it remains legitimate, fair, meaningful, responsible, and governable across the states it can reach. The question is not only, does it work? The question is, can it enter a state it should never be allowed to reach? That is the purpose of the admissibility verification model, and that is why P distinguishes performance from governance. Philosophical Intelligence Institute, a discipline, not a trend, a framework, not an opinion.